I want to go over how to multiply and divide radical expressions. Let's start off with something that you probably have already seen before. Let's say you have the square root of 5 times the square root of 20. And you want to multiply these radical expressions. Note that each piece of these have one term. So if you were to go and multiply them, you just have the square root of 100, which equals 10. But what if your two expressions, let's go 3 plus the square root of 2 times 1 minus the square root of, let's use 3. And we want to define what the multiplication of this. Because there are two terms in each expression, you cannot just multiply across like you could before. You need to do foiling. So you have to multiply the first, the outer, the inner, and the last. So what you end up here with is 3, that's your first, outer, 3 times the square root of negative 3, so negative 3 square root of 3, and then square root of 2 times 1 is plus the square root of 2, and then the square root of 2 times negative square root of 3 is negative square root of 6. And because the square root of 3, square root of 2, and square root of 6 have nothing in common, this is actually the multiplication, and you can't do anything with it. Let's look at one more of those. Alright, so let's multiply these. We have 4 times 4 is 16. 4 times the square root of negative 5, or negative square root of 5 is minus 4 square root of 5. And then we have plus 4 square root of 5. And then minus the square root of 25, which is 5. The minus 4 square root of 5 and plus 4 square root of 5 do cancel, and you have 16 minus 5, which is 11. Notice that these two factors are pretty much the same, they're just opposite signs. Those are called conjugates of each other. And whenever you multiply conjugates of radical numbers, the square roots will go away. If I have a plus the square root of b, and I want to find what the conjugate of that is, you just have the same numbers, but then opposite signs. So a minus the square root of b. Whenever you multiply conjugates, the square roots will disappear. So you would have 9 minus, or plus, sorry, not plus, minus 2, which ends up being 7. When we're dividing radical expressions, what is the most important thing here is that you do not want any roots on the bottom, no matter what the nth power is. So, let's look at some basic ones that just have your basic, let's say the square root of 3 on the bottom. What we want to do is we want to rationalize the denominator, meaning we want to get the square root out of the denominator. So I'm going to look at the bottom here, and I need to multiply 3 by another 3 to be a perfect square root. So I'm going to multiply the top and bottom by the square root of 3. 4 square root of 3 over, what is the square root of 3 times the square root of 3? That is the square root of 9. And the square root of 9 is 3 So we've gotten the square root out of our denominator. Now, if you can reduce it all, please do. But in this case, you can only reduce the constants in front. And since 4 does not reduce with 3, we are done. Now, you can do the same thing if you don't just have a square root. Let's look at this. If I have 3 over the cube root of 8. No, sorry, 8 is a cube root, so let's go the cube root of 4. That's better. 4 is not a cube root, but I need to think about what can I multiply 4 by so that it is a cube root. In this case, if I multiply the top and bottom by the cube root of 2, 4 times 2 is 8, and 8 is a perfect cube. So we'll put a cube root of 2 times the cube root of 2. That ends up being 3 times the cube root of 2 over the cube root of 8. And now 8 is a perfect cube root, which is 2. This 2 cannot go into this 2 because of the root. And that 2 cannot go into 3, so we are done with that problem. Now those are your basic radical expressions that involve division, but sometimes they can get a little bit harder. So let's take a look at that. Okay, so in this case we have not just one number on the denominator, but we have a pair of them. Think about what we've seen in this video that eliminates square roots from the denominator. And that would be the conjugate. So what you can do is you can multiply the top and the bottom by the conjugate. Now I can do that because 4 plus the square root of 2 over 4 plus the square root of 2 is 1. So what you end up doing is we have to distribute the top and the bottom. We end up with 20 plus 5 square root of 2 over 16 minus 4 square root of 2 plus 4 square root of 2 minus 2. And those cancel, and we end up with 20 plus 5 square root of 2 over 16 minus 2, which is 14. 14 does go into 20, but it does not go into 5. So you can either break those up into 2 terms or just leave it as is, which is what I'm going to do. Alright, let's see one more of those. Okay, this is the last one where we need to rationalize the denominator. You can also rationalize the numerator if you needed to. That's something that maybe you'll see in calculus. But in our case, we just want to rationalize the denominator. So I'm going to multiply the top and bottom by the conjugate of the denominator. So we have 6 plus the square root of 3 over 6 plus the square root of 3. And we will need to make sure we FOIL each of these. So we've got 18 plus 3 square root of 3 plus 6 square root of 3 plus the square root of 3 times the square root of 3, which is just 3. All over 6 times 6 is 36 plus 6 square root of 3 minus 6 square root of 3 minus 3 squared square root, that's 3. Okay, one thing that's important is do not be tempted to cancel any of the square roots of 3 out because, from the top and the bottom, because they're being added. But on the top, we can combine the square roots of 3 because they do have the same variable. So we have 18 plus 3 is 21. 3 square root of 3 plus 6 square root of 3 is 9 square root of 3 over 36 minus 3, which is 33. Now something interesting happens here, and that is that every single term has a multiple of 3 in it. So you can go through here, and I can factor a 3 out of the top. That would be 7 plus 3 square roots of 3 over 33. That 3 will go into 33 11 times, and we end up with 7 plus 3 square roots of 3 over 11. And there is our final answer.